All right, well, thank you everyone for joining us today for the Minroad Ncad sponsor meeting. We'll be focusing on the cracking group experiment with also looking at the additive group future focus that we'll be working with. My name is Ben Worrell. I'm with the Minnesota Department of Transportation. I'm a part of the Minroad team. I guess a couple things related to, again, first of all, I'd like to thank everyone for their participation and their support through this experiment. Without you, this would not have taken place. And both the Minroad and the Ncad staff appreciates that. Some housekeeping. Again, everyone, would you please mute your line if you have not done so already? If you're not speaking, mute your lines. We'll have an open discussion after each presentation. You can do that either verbally or through the chat box. We'll be monitoring that. And the goals is, again, is to update the sponsors on the progress, discuss future activities, and again, we're planning on a meeting in the spring of 2022 at Ncad. That date has not been determined yet. So let me go through the agenda. And again, if you haven't done so yet, please mute your lines. We have a few people that have not muted their lines. If not, can someone from MnDOT mute them for me? I appreciate that. Again, today we'll be focusing on the cracking group experiment. The first speaker will be Michael Vertis talking about the Northern Cracking Study final report and overview that we've observed with the work that we've done up here, mostly looking at thermal cracking. Buzz Powell will be talking about the construction that took place on the Ncad test track this summer and summarizing the efforts that have gone on there. Randy West will introduce us to the additive group study and the progress that's been made so far and how that's been incorporated into the test track down in Alabama and how it reflects on the work that we're going to do in 2022 up in Minnesota and our construction that should be taking place. Michael Vertis will cover that with the reflective cracking challenge and the different aspects related to that, and also tying in some of the work from Missouri that's going to be taking place. And then we'll do a wrap up at the end. So we have 2 hours that will be covering a number of different topics. And with that, let's lead right into Michael Vertis and the Northern Cracking Study final report. So Michael, if you could share your screen. And again, everyone, please mute your lines. And we'll have a discussion after Michael's done. So thank you, Michael.
All right, good morning, everyone. Can everyone see my screen, Ben?
I can see it.
Okay,
thank you.
Good.
And also, please reduce your image if you're not speaking. That way, maybe we can help with the bandwidth if there's any issues that for individuals. Thank you.
Yep.
Go ahead.
Good morning, everyone. I am Michael Vertis with the Minnesota Department of Transportation at the Minroad Research Facility. Today, I'll be talking about the northern portion of the Minroad Ncad cracking group. And if you look on the agenda, the actual title of this presentation is the Northern Cracking Study Final Report Overview. So I'll go ahead and address the final report now and give all of the sponsors a heads up that we will be distributing the final report for sponsor review shortly. We're looking for just a read through feedback, especially related to the conclusions, and then we'll host a meeting where we address those comments, and then we're hoping to publish by the end of this year or early into 2022. One of my challenges in putting together the presentation for this morning, especially as Carolina Rodesno and I have been working on this report, is trying to take a large project that we've been doing for 5 years and breaking it down into a 25-minute presentation. We could probably talk about this project alone for at least a day. So if there's something you're particularly curious about, please see the report for more information on construction, FWD, instrumentation, details on the field performance, and laboratory testing. So getting into what I will cover today in the limited time that we have, I'll provide a background of why we did this experiment, what sections we were looking at, and then what happened at Minroad, and then the lab correlations, conclusions, and takeaways. So the cracking group experiment was initially started with Minroad and Ncad, and the overall objective was to correlate the whole suite of laboratory cracking tests to field performance. So we did that with test sections at Ncad and at Min-Road. The sections at Ncad were focused on top-down cracking, and the Min-Road sections were focused on low-temperature cracking. The Min-Road sections are a little bit different than those at the Ncad sections. For those that are more familiar with Ncad, Min-Road is live interstate traffic on our test sections. So we construct our pavement test sections a full interstate width. So we have 2 travel lanes, 12 feet wide, and then we have a full paved shoulder. In this experiment, we had a common structure of base and subgrade, and we were only changing the 5 inches of asphalt. The 5 inches of asphalt was constructed in 2 lifts, and the shoulders were also built with the same structure as the main line. Now, looking at the mixes that were used, so we had 8 sections at Min-Road, cells 16 through 23. These sections were designed, especially the mixes within the sections, were designed to show a range of low temperature cracking potential. And generally speaking, the lower the cell number, the higher the cracking susceptibility that was intended. The mixes basically start off of cell 21, which would be the typical MnDOT mix that would be used on this. It's a PGH-34 binder. And then from that mix, we have cell 18, which is the -22 binder version. So we selected a binder with a low temperature grade that was 2 grades away, really trying to separate the low temperature performance. So 16 through 19 used a -22 binder, and then 20 through 23 had a polymer modified binder, or slightly different binder, with a -34 grade. However, our extracted binder properties that we got from our virgin materials really kind of drew all of our mixed properties to the same general area. So instead of getting a 12-degree separation or 2 grade separation, our wrap properties and our virgin binder properties kind of brought us to a pretty narrow range on our low temperature cracking. So we had on the warmest range, we had a -25, and then on the coldest, it was a -20 or -32. So we were a lot tighter on that window. And that's because the wrap and the raz that we used were relatively soft. And then the virgin binder that was supposed to be a -22, and it was graded out to a -22, but in reality, it was closer to a -28 on that end of it. Really looking at the extracted binder properties, it's cell 20 really is the only noticeable difference in PG grade, extracted PG grade, and it's the high end that you see that 63 on the warm temperature side. So now getting into what happened over the last 5 years at Min-Road, one of the key aspects that we monitor at Min-Road and why the Min-Road facility exists is the harsh Minnesota winter. And you can see that our temperatures that we had ranged anywhere from a cold of -30 air temperature in 2019 to a high of 100 degrees this June. And then looking at the pavement temperatures, or in Celsius looking at these, we were all the way down to -29 degrees in the pavement, and then all the way up to 59 degrees. So these Min-Road sections are open to interstate traffic, and we had over 4 million easels of traffic applied to the sections during this time. The ride held pretty steady throughout the experiment. There's a couple things that really jump out at you when you look at this slide. The first is the peaks that we sometimes capture in our early collection. This is attributed to the spring thaw, and if we do capture this peak, it pretty much levels out the next month on our subsequent data collection. So we saw that 3 out of the 4 Marches that we collected. We did not see that this March, but we did see this March cell 18 here had a big spike in the roughness value, which I'll talk about more. The other thing that stands out is cell 23 was built rougher and held that roughness throughout the test section, so it was built differently. Rutting performance, there was very minimal rutting throughout the experiment. The only reason that I include this slide is to show that cell 20, that softer extracted PG63 on the high side, did not show any difference or rutting or increased rutting. So that was good reassurance on that. Now getting into the cracking performance, which really is what kind of controlled this experiment. So we had very little distress from winter or through the winter of 2018, 2019. So through 2 years, 2 seasons, and then come early 2019, we had a lot more cracking and a lot more distress than we were expecting. So putting these numbers into context, I know I have a large scale here, but this is total percent cracking in the traveled lanes. So this is both the driving and the passing lane combined. Total percent cracking for this experiment, for a low temperature cracking experiment, if we had a section that had transverse cracks every 50 feet all the way across, we would consider it to be kind of completely cracked, and that would be 2% of the lane area that would be cracked. So, and when we saw values this high, we knew something was going on, and we were seeing distresses that looked like this, where we had large fatigue or load related cracking in the wheel path that we were not expecting. And then we also noticed that we had a lot of deterioration along the longitudinal construction joints. In particular, if you look at this one here on the far right, you can see the construction joint, and then you can see subsequent cracks developing all the way off of that joint and then into the wheel path here. So we conducted a forensic investigation. We took cores in distressed areas, non-distressed areas. We took cores over transverse cracks. We basically took cores over every type of distress we saw, trying to capture what was going on. The majority of the cores that we took, and especially the cores that were in the fatigued areas, we found that there was delamination. So the cores were coming up in 2 pieces, and the cracking was only in the surface, and we could not find any distress in the underlying lift. Then come 2020, we did, through the winter of 2019 and 2020, we saw an increase again, a substantial increase in the amount of cracking we saw. So we further investigated the delamination that was going on. Really, we were trying to answer the question of were the sections built with a poor bond, or was it a poor bond that resulted later? And we took cores throughout the sections every 100 feet in non-distressed areas, and we found adequate bond strength in all the cores in all 50 of the samples that we took. So bond strength was not an inherent issue in the sections. It was something that was developing later through other mechanisms, weakening of that bond strength. Some of the pictures that we saw, or the conditions we saw in 2020, you can see increased distress along this shoulder edge. And that distress, there's some potholing here, and then cracks creeping out into the wheel path and into the lane area. And then further deterioration of our longitudinal joints throughout, even after crack sealing was done. So moving forward to 21, we had an even greater increase in the amount of total cracking we had. And that is because in March of this year, we had some more potholes along the edge line. We got an air compressor to clean out the potholes so we could patch them. And we started seeing with the air compressor geysers 10 feet away. And the pavement was completely delaminated, as you can see with the shovel here in this video. We we're fortunate enough at Minroad to have a partnership with Caterpillar, and Caterpillar was able to mill these sections and pave these sections for us through a partnership. Really beneficial to us and Caterpillar. They want to put hours on their equipment, and we have lots of construction work that needs to be done. One of the really interesting things for us as we milled these sections, there was no observable distress in the underlying layer. So you can see in this image the types of potholes that were throughout. And after we milled, we did not see any distress. There was a couple of the transverse cracks that were in the lower lying structure. So I can't say there was no cracking in the bottom 3 inches, but it was only the transverse cracks that were full depth through there. So Caterpillar milled and paved for us, and since paving in May, we have not seen any distress in these sections. So drawing conclusions from the field performance, we can see that there was a wide range of performance was observed. And it's important to see that the rutting and ride values were still very good until the potholes or severe distress occurred. That tells us that we had a sufficient structure there in the first place, and really it was just the top 2 inches of the mix that wore out, and not the overall structure. So the majority of the observed cracking is believed to be a result of water intrusion into the longitudinal construction joint and then a weakening of the bond between HMA layers. If you remember from previous presentations throughout this experiment, cell 23 was excluded from the lab field correlations. It was built with a higher roughness. There was a bump prior to the section that had a weak base and subgrade. There was moisture issues in there. We did a TRB paper and have presented on this several times, and there's much more detail into why that decision was made in the report. But overall, care must be taken when using the Minroad Cracking Group field performance data to correlate to laboratory tests. When in 2020, in March 2020, Randy West and Nathan Moore came from Ncad to help with kind of our forensic investigation, get some extra eyes on these sections. And when Randy was here, he observed that the shoulders had transverse cracks in them, and they were not influenced by some of the other issues that we were seeing with the trafficked or mainline portions of the test sections. So we started collecting distress surveys on the shoulders and using the shoulders as a correlation to our laboratory tests. So if you remember from one of my beginning slides, the shoulders were built with the same mix and same thickness as the traveled lanes in these sections. Another reassuring aspect is when we looked at the shoulders, we were matching the same trends that we were seeing in the main line and the same expected trends that we were having with these mixes. So the mainline section, cell 20, did not have any cracking, and also the shoulders did not have any cracking. And then you can see the difference, expected differences as we use that -22 or change binder grades with cells 16 through 19. Cell 22 had a large amount of transverse cracking in the shoulder, and these are 10-foot shoulders, 500 feet long. So if you're thinking that 682 feet of cracking is a lot, it is. This is what we were observing in the shoulder. So we have transverse cracks repeatedly after one another. So using the shoulder data to correlate to the wide suite of laboratory tests. So this is normally the portion of the presentation that I would turn over to someone at Ncad, and they would discuss in more detail each of the tests and correlations. Unfortunately, we don't have that much time today. So I'm just going to provide a summary of the correlations that we saw and then highlight a couple of the tests and what we were looking at in some of our analysis. So the best correlations, as you can see here in red, were the DCT fracture energy. We did all the correlations on reheated plant mix, and then also plant mix that was reheated and critically aged. So the best correlations were the DCT and then also the Ncad overlay tester, especially the beta parameter. So looking closer at some of our DCT results, Here at MnDOT, we were pretty happy to see that the threshold that we commonly use for reheated mix of DCT of 400 millijoules held with these sections, with the only section that had the worst performance was cell 22, which is the only section that fell below that line. Another thing that was important to see, and we saw it only with the critically aged, cell 20 was predicted as the best performer or had the highest DCT fracture energy. And then cell 20 subsequently was the best performer in the field with the lowest or with no cracking. We found similar trends in results with the Ncad beta parameter. Cell 22 was identified as the worst performer. Cell 20 was also identified as the best performer, and we had strong correlations both on the reheated and critically aged. So we looked at all of the tests in a similar manner. Were they able to identify the best performer and the worst performer? We had good results with the semicircular bend on the reheated, able to identify the best worst performer, but not so on the critically aged. So wrapping it all up and concluding the experiment, we saw a wide range of field performance. The rutting and ride were very good until literally pieces fell out of the road. The cracking observed was caused by multiple mechanisms: construction-related, load-related, delamination, environmental. And we also, the cracking that we saw, especially the low temperature cracking, was influenced by the narrow range on our extracted PG grades, and then the structural delamination that we observed. However, we were able to draw a lot of conclusions out of the low temperature cracking on the shoulder. The DCT had the best correlation with the field. The threshold that we used for the DCT accurately identified the worst performer, which was reassuring for us at MnDOT. We've spent a lot of effort with the DCT, and we're continuing to find ways to use the benefits of the DCT, but incorporate them into a more field-friendly or a faster type test that gives us the accuracy of the DCT, but on a faster turnaround. And then the Ncad overlay beta parameter also showed very good correlation to the field. So some of the quick takeaways that you can have, really want to be careful not to throw the baby out with the bathwater with the field performance that we have here, because even in the main line or traffic lanes where we saw an array of distress or mechanisms causing the distress, the general trends that we expect with some of these mixes and the one-to-one mix comparisons still held true. So we saw better performance in cell 21, which is our PG minus 34 binder, than we did in the unmodified minus 22. Even in the unmodified minus 22 binder, we saw better performance when we added more binder, the comparison between cells 18 and 19. Similar results in the report, or similar comparisons, are made on kind of a mix by mix basis for the laboratory tests in the report. Carrying these efforts forward into MnRoad 2022 construction and the MnRoad Reflective Cracking Challenge, which I'll be talking about later this morning with Randy West. We're really going to pay special attention to ensure consistent base throughout. We're planning on having increased moisture sensors in our base and subgrade, and especially identifying cell 23 and remedying that early on in the construction. We are going to pave the driving lane 1 foot wider. So in this 2016 construction, our driving lane was paved 12 feet wide. We're now going to pave 13 feet wide, just to make sure that our longitudinal joint is outside of the stripe at all times. MnRoad has a little bit of a curve, and if you saw in some of the pictures, that longitudinal joint was either right on the stripe or inside the edge stripe itself. We will be using a longitudinal joint sealer during construction, and then we are going to have a more aggressive crack sealing approach. However, the frequency and the timing and all of that needs to be carefully considered by the tap. And then one of the things that we're pretty certain that we're able to incorporate into the contract is we're actually going to pave our sections an inch thicker, the underlying layers, and then mill with our partnership with Caterpillar. We'll mill an inch and then apply our final lift. That way we are applying our overlays to a milled surface, one being more representative of how we apply overlays in the field, but also really trying to eliminate any potential for delamination. With that, I'd like to acknowledge just the Minroad research team that makes everything possible for us, and then also Dr. Carolina Rodesno at Ncad, who have been working closely with on this project, especially on the laboratory side of things. And I will open up to questions now.
All right. Well, thank you, Michael. Had a couple comments on our different participants as they're joining. I would like, if Lauren Dow is on the line, maybe we can talk in the next presentation to try to get that removed so everyone doesn't see that. Sorry about that. Any questions for Michael? Let's see, Molly asked which route were these sections from?
This is I-94 westbound.
And Tom asked how deep is the significant moisture penetration into the HMA during the freeze-thaw season?
Do you want to handle that one, Ben? That's a...
I guess when it freeze-thaw seasons, I mean, we do get, if you're talking whole pavement-wise, we can get up to 5 feet of frost. So there'll be a freeze-thaw cycles going all the way down. The top surface goes through more freeze-thaw cycles just because it's near the surface. It's more affected by temperature. It was interesting. We had a study looking at what would the effects of freeze-thaw cycles with warmer winters. They found that there's less freeze-thaw cycles with our warmer winters, kind of global warming type of thing that went on. When you're talking about just how many cycles there are, I guess I don't know that offhand. Again, our winters vary quite a bit. It all depends where you're hovering between that 32 and the above and below that. But with the moisture, we do see our pavements get quite moist, you know, as things freeze. It is a pretty nasty environment, and you can see how delamination could take place. So I kind of danced around that, Tom, a little bit. Maybe that's a longer discussion later. Anything else you'd like to add to that, Michael, after hearing me go in circles?
No, you answered it better than I could. I would just add that our moisture sensors in these cells were, the deepest we had was 24 inches for our actual moisture content monitoring.
Okay.
And that was just based off of the structure that we had. So basically, when we install moisture sensors, we try to characterize the layer with moisture sensors in the top and then the bottom.
Right, and they're mostly in the base materials. They're always in the base materials, unbound materials.
Correct.
Bernard, you had your hand up. If you have a question.
Yes, I'm really impressed by the presentation given by Dr. Vertis. I just wanted to ask a question because every day we're finding out better ways of evaluating the performance of our systems. And I'm not a spy. I'm an all-rounder. I'm not just a concrete guy. I'm everything. So my question to you is, I know this was a very short presentation, but did you do any form of probabilistic evaluation in your comparison, or did you just make them categorical?
Go ahead, Bernard.
Oh, I was just wondering if you heard my question.
Yes, I heard your question. And if I'm understanding correctly, at this point, we've only done categorical. We have not.
Do you intend down the road to do some kind of reliability analysis,
Yes, we do, but it is not something that's currently included in the report that we're sharing at this time.
Okay, thank you.
I guess we can handle one more question. Doug Carlson asked, is there any significant difference in the binder absorption between the limestone and the granite aggregates? Michael?
Off the top of my head, I'm not sure. Minnesota uses a asphalt film thickness, which is a little bit different design for binder content than other states. So if there is a difference in absorption, we would capture it with the effective binder content being the same.
But again, the limestone and the granite are way different materials. I would assume the limestone would absorb more than the granite just because of hardness.
That would be my general guess also.
Yes, okay. With that, we'll probably need to move on. I guess right now I'll take a little quick break and say, again, mute yourself and also take away your image if you haven't done so already. I believe everyone has. And thank you very much, Michael, for your presentation. Lauren, is there a way we can get the pop-ups not to show up? And we'll be working on that so that hopefully we don't see that in the update next presentations. So our next presentation is the Ncad test track construction update from Powell. Buzz, if you could please share your screen and start your presentation. We can see it just fine. We haven't seen the presentation quite yet.
How about now, Ben?
That looks wonderful. Thank you, Buzz.
All right. Well, thank you for the introduction, and good morning, everybody. I'm really pleased to meet with you this morning and provide you with a kind of a high altitude overview of our rebuild effort this past summer for the 2021 Ncad pavement test track. Of course, like others, I want to start out expressing some appreciation and first and foremost to the public and the private funding partners that make the research possible. Also, Aztec and Road Tech for donating equipment and expertise. Also for working in HOM for doing the same thing, equipment and expertise. Vulcan Materials donated a lot of material for our bases and for our mixes, and there are a lot of other aggregate suppliers and contractors that donated material as well. And in the future, we'll do everything we can to develop a comprehensive list for that. High Tech Asphalt Solutions donated a feed system and a lot of raw materials. Ingevity provided us with an additive pump and a lot of different admixtures, liquid additives to pump into the AC system. Argon Asphalt and Emulsions was our asphalt supplier, and we contracted with them through a competitively bid contract, but then they also did a lot of things behind the scenes to support us from a logistics point of view. They really went above and beyond just the role that they played, the contract relationship that they had with us. I'd say the same thing about East Alabama Paving. You know, we competitively select them, or we select a paving contractor every 3 years. East Alabama Paving has been our contractor since the 2003 track build, and they always do a lot of extra things to make our work possible that really go beyond the contract. Lee County, the Lee County Engineering Office, they helped us with subgrade materials. Those of y'all have been to the track know there's a quarry right down the road where they essentially mine their subgrade materials, and they helped us with that this year. Chris Clark Grading and Paving helped us with some equipment and also some labor on the track. And then finally, the Ncad team and Auburn University for the track build. There are a lot of really special people at Ncad that make this work possible. I get to do the presentations, but there are too many people to mention really that play critical roles in making this research successful, and I'm very grateful for that. And then Auburn University on the back office side with bidding all the contracts and those types of things, I appreciate their perspective on this type of thing, because they they're not obstructionists in helping us to procure. They're very much facilitators, and it wouldn't be possible to do this work without that kind of an attitude. So many of y'all probably seen me present this slide before. It's a schematic layout of the track that allows us to do really rapid budget scenarios and kind of experiment with moving test sections around and figuring out where everything is going to need to be placed. Where you see green on this layout, that is a traffic continuation. Yellow is a mill and inlay, and then red is what we consider a structural test section. The structural sections, we only put those in the tangents. We don't put instrumented, deep rebuild sections in the curves because of the different vehicle dynamics. The location of sections must meet research needs. For example, if you're looking at reflective cracking in a mill and inlay, then there's got to be cracking underneath that makes that possible. So we can't put sections just anywhere. And we've been very blessed to find good matches for most everything everybody wanted to do. We do have to plan around traffic continuation. So sometimes, like, it'd be really nice to put all those red sections together, but it's just not possible to do that. So we put as many of them together as we can and try to make placement just as logical as possible. And sometimes even states prefer not to relocate, and that complicates things just a little bit. But of course, we really want to accommodate everybody's research needs in the best possible way. So to give you a feel for what this track looked like, we ended up with 32 sponsored test sections, and for Randy's benefit, for the Ncad team's benefit, I think when we did our budget brainstorming, I believe we planned on 31, so that we were really in the ballpark with that. We were very, very close. 16 of those are traffic continuations, 7 are mill and inlay sections, and 9 of those are structural test sections that were deep rebuilds. So we repaved or rebuilt 16 test sections, and that's about a third of the track. Typically, in these rebuilds that we do every 3 years here, we end up rebuilding about a third of the track. So when you hear us talk about rebuilding the track, if you're not familiar with the research, you might get an image in your head of us rebuilding everything, and we don't do that. When we built the first track, we built 46 unique test sections, and then pretty much every 3 years after that, we rebuild about a third of what we have in place. I'm not going to spend a lot of time on traffic continuations because I'm supposed to be talking about construction, but because that is part of the kind of the sponsor scenario, I wanted to show you what we are continuing. There are 16 sections. We got high rat with recycling agents. We've got a foamed CCPR base, some high performance thin lays, a 1/2 inch thick and 3/4 of an inch thick, interlayer strategies for crack prevention, and then we've got a soybean based polymer modified asphalt. And as I go through my slides, when you see a line in green, that means that's a easy visual indicator that that's a privately funded test section. And for those of you not familiar with what we do, private sector pays the exact same cost as agencies pay. So this is very, very expensive research, and it represents a significant investment on their part. In that picture down on the bottom of that slide, those are the interlayer test sections that we have in place in N12 and N13 for Georgia. And if you're not familiar with what we do, I make the mistake of taking for granted that everybody knows this, but when you see a test section designation, for example, in this first line, N3, that means test section number 3 on the north tangent. So you've got north, south, east, and west, and then sequential numbers that range between 1 and 26. More traffic continuations. We've got balanced mix design with recycling agents and gradation changes. We've got the structural benefit of base stabilization and subgrade modification, long-term benefit of surface rejuvenators, full depth rapid rebuilds, rejuvenation of an open graded friction course surface, and then the impact of density on performance. And that rejuvenation, that's the surface application of a new rejuvenator that's a privately funded test section. So something is done to that section, but it's funded as a traffic continuation because the cost of application is borne by the company that is sponsoring that section. And that, again, you'll get more details as time goes on for these test sections. So this is hopefully gives you a feel for what our stockpile yard looks like when we're building the track. we long haul materials from all over the country, from as far west as Oklahoma and Texas, and as far east as Virginia, and you end up with a lot of relatively small stockpiles that are just scattered all over the place. And I wanted to share this picture because Vicki Adams is in it, in the Ncad truck there, and Vicki works herself to death, receiving all these loads, making sure we don't contaminate piles by dumping the wrong, unloading truck in the wrong location. And she does gradation measurements for us and does moisture contents every day before we run, and then again after the rain. And I also like this slide because we have this system where she puts pile lines out there with name designations on the stockpiles, and then a bucket top, the bucket top that says RAP and the one that says RAS next to it, and that means that material is what's supposed to go in the RAP bin for the run that we're currently making. So we got 7 cold feed bins and then 2 recycle bins. So there'll be bucket tops out there to help the loader operator know this is the stuff I need to be putting in bin number 1 or bin number 3 or the RAP bin or the RAS bin. And it's about the only way we can keep things straight, because it's very hectic as these stockpiles are continuously coming in. I also want to share this slide because we don't order less than 3 loads of anything when we're going to run. And the reason for that is because when you put this stuff on the ground, you end up having ground waste, and then you put it in the bins and unload the bins in between runs sometimes. And this slide also shows you why you have ground waste and why we need to haul at least 3 25-ton loads of material, even when something is a relatively small percentage in the mix, like the shingles that you see right there. So for the build this past summer, by my count, we had 53 unique stockpiles, 42 virgin stockpiles, 10 different wrap piles, and then 1 shingle pile. We worked 30 work days within 47 calendar days between August the 12th and September, I think, the 28th. And of course, we didn't work on Labor Day. We had Tropical Storm Fred. We had Hurricane Ida. And then we were dodging rain for a lot of the summer, but those were the big events that kind of chopped into the calendar days for us to come up with 30 work days. We ran 27 unique mixes this summer, and then 29 trial mix runs in support of those 27 unique mixes. And when we say trial mix, what that is in simple terms is it's a practice run where we look at the job mix formula, we look at the gradations of the materials on the ground. We set up as close as we can to the job mix, or the design gradation. We run it through the plant, and we run enough material with waste on either end so that we can sample it and test it in the lab to make sure it satisfies whatever requirements are in place for that mix. And then when we're confident of that, sometimes we do multiple runs. And when we're confident of everything, then we'll actually do a pave run, and we'll place material on the track. So a trial mix run is a practice run. We had 11 unique hot mix asphalts this summer. 3 of those we hauled and ran off of heated tankers. So at our plant, East Alabama Paving's plant, which we kind of claim it as ours because we've been working with it since 2003. There's 1 neat asphalt tank and one stirred polymer asphalt tank. So those 11 unique hot mix asphalts, only 3 of those were not run through either the neat asphalt tank or the polymer tank. Most of those are run through the polymer tank. So you can imagine the puzzle of the track. I'm sharing this with you so that hopefully you can get a feel for the effort that Jason Nelson, the test track manager, and I put into making sure that everything fits together and we have uncontaminated material in the tanks, have completely empty tanks or heated tankers to run off of. We built the track this summer with 3 asphalt plants, 1 Aztec double barrel plant, the plant over at East Alabama Paving, and then Workgen brought in a KMA plant for cold recycle mix, and Pug Mill Systems brought in one of their pug mills also for cold recycle mix that I'll kind of say more about here in just a minute. We used 10 hot plant additives. 7 of those were solid additives that we ran through our High-Tech Asphalt Solutions feeder system. And then 3 were liquid additives that we added through a multi-port injection system we have in the AC supply line with a calibrated Ingevity pump, a pump that Ingevity provided not just for their material, but also for some other materials that we ran. We had 4 unique cold recycle products. 2 of those we ran in the KMA plant, and 2 of them in the pug mill. And again, my focus is the construction effort. You're going to learn more about all these things as time goes by. We'll break all this down with the sponsor meeting that we'll be planning for this coming spring. And we used 3 different tack products. 2 of those were hot applied, and 1 of those was an emulsion in support of the specific research that was being done on those test sections. So the new mill and inlay test sections, we had 7 of those. 3 of them are balanced mix design with recycling agents and gradation change, that kind of thing. We have a BMD section. One of the more interesting sections is for Tennessee in S4, and it's a super page gyratory compactor design where we're looking at using Marshall equipment for quality control testing of balanced mix design. Bond strength with different tack products and or rates. Friction performance mix optimization. So this is for Kentucky, where we're supporting Kentucky's implementation of balanced mix design, but also with a laboratory friction requirement. Nathan Moore is our lead on that research here at Ncad in the laboratory. And then high performance open graded friction coarse surface for Alabama in section E9. And then we use some materials that can sometimes be challenging in Alabama, but our objective was to not make the experiment easy with really easy materials or really high quality materials. We wanted to use common materials and develop a high performance system for those materials for Alabama. We had 9 new structural sections that we built this summer, and these are where we build from the completely remove the test section and then build from the subgrade up with new subgrade materials, new base materials, and then new surface. All these are fully instrumented for high speed response by Dave Tim and his team with strain gauges and pressure plates. So for Virginia, one of the more interesting sections on the track is what's the minimum HMA thickness that we need over recycled cold recycle mix. That's in section S12. In the additive group, the objective of the additive group that Randy is going to provide more details on is to really quantify the impact of the additive on pavement life. And I've got AG in green there because in a public-private partnership kind of way, the vendors paid for phase 1 laboratory studies. The state DOTs and FHWA in partnership that are paying for the overall experiment reviewed all the laboratory findings with BMD and testing and modeling, and they picked what was going to be actually built on the track this summer. We did have a couple of privately funded what we call AG plus test sections that are identical builds with other materials, and one of those is a product called Sigma Bond, and the other one is a BASF product called B2 Last, and both of those are really high polymer performance type products, where the objective of the study, as I said, is to quantify the benefit of those products on pavement life, or the impact on pavement life. So as I said, the vendors paid for the phase 1 laboratory testing, and then these agencies, in cooperation with each other, in partnership with each other, went through the selection process and picked what would be put on the track through really what was a blind ballot process that was managed by Ncad. This is the construction schedule that I would routinely send out to stakeholders as we worked through construction this summer, and I wanted to take just a few minutes to go over this. Thankfully, one of the benefits of web meetings is you can see a little bit more with a smaller font. So this is the exact schedule that I sent out to everybody, so this is what we defined as a sublot in our contract process that we built this summer. And I wanted to say a few things about it related to construction to give you a feel for how everything went. And the first thing is related to instrumentation. So Dr. David Tim is our PI on or at least a co-PI on all the instrumented test sections. So when you see an H in that column, that means we had to have calibrated gauges installed prior to the placement of the surface. And so we would complete a subgrade, install pressure plates, complete a base, install pressure plates and strain gauges, and then we could pave. and the supply chain hit us really hard with instrumentation supply this summer. Dave Tim's team, Dave and Matt Sasser, and then his students did a great job of staying ahead of paving, and we were really concerned that we were not going to be able to get gauges that we ordered way in advance, and it was gonna cause a hot stop in our paving and create all kinds of problems. But praise God, Dave was able to get his hands on gauges, and with some cooperation from some off-track research that he was doing, and was able to stay ahead of us, and that was something that really scared us. Another logistical challenge was all the different binders that we ran on the track, and I gave you the count in that earlier slide, but this construction schedule kind of embedded in it is the logistics of making sure that stuff is here. So when I would send a schedule out and say we're going to run this binder on this date, just imagine that material had to be produced in a very remote location and long hauled, and oftentimes, and had to be there at the time that we needed it to be there. So, this kind of work can't be done without a tremendous amount of cooperation by many people. These are materials these are kind of special details, and then materials that we added in the high-tech feeder machine that was there at the plant. So it wasn't as complicated as the gauges or the liquid asphalt, but because it's easier to get things shipped that are just going to be fed through a system like this. But because of the supply chain problems this summer, it was pretty routine to have someone overnight ship us a pallet of something, only to find out the next day that it was in some state that it wasn't supposed to be in, and then we had to hustle and get that on site. So it sounds simple, but this summer nothing was simple when it came to the supply chain disruptions. And then the liquid additives that we pumped in, you see in that next to last column, and then finally the different tacks that we use. You see a lot of NAs in there because those are all structural test sections where a tack product was not used. This is a shot of our Aztec double barrel plant being erected back in 2003, the first year that the East Alabama Paving built the track with us. They actually bought this plant we were the first project that they ran with it back in 2003. You probably see this as my virtual background a lot in many of the presentations that I do. This is the view from the control room, and since this plant was put up, 2 additional cold feed bins have been added. A second mix silo has been added. A load cell controlled shingle bin has been added. A green foam system has been added, and then several different things were added to it from a plant automation project that Randy was a PI on back many years ago that still benefit us when we run mixes on the track. One of the things that we added in this cycle was the ability to really remove the -200 in the mix in a highly controlled way. This system was amazing, is really simple, and on the baghouse return, there's a digital controller for this. When you set it on 5, you're removing 1% -200. When you set it on 10, you're removing about 2% -200. So it was a blessing, and really helped us to meet the volumetric requirements on some of the volumetric mixes that we ran this summer, and it's going to be a great tool for us in the future. Because this is a computer controlled plant, and it really always has been. I think it was the first computer control plant that Aztec built back in 2003. This is some data that's available to us through the computer system from Randy's plant automation project, and the top plot is the viscosity of the liquid that's circulating in the hot oil system on the plant, in the AC supply system, and then that bottom plot is the temperature. So when we swap from one of the tanks in circulation to a tanker, and we start pumping off a tanker, this is really helpful, because you can see when this plot stabilizes, that means we've got good consistent material in the line, and you see the same thing kind of with the temperature plot down here. It's just a really helpful thing for us to have. Again, because it is a computer controlled plant, when Jason and I are there and we're running the plant with our contractor, we can stand there and kind of look over the operator's shoulder and see plots like this to know that everything is under control. This is mixed temperature, so we know when we're kind of in a steady state with mixed production. So this would be our waste phase of mixed production. This line is the baghouse temperature line. So when that line fluctuates, that means the loader operator put something wet in a bin, and we need to be really careful because that can cause the asphalt content to fluctuate. And then this is the virgin weighbridge and the recycle weighbridge. So we have really good visual indicators of where are we in kind of steady state mixed production that help us to do these short runs in a really precise way. In the AC storage tanks, the plant on the left in this graphic is the neat asphalt tank, and then tank number 1 is a polymer tank. So we can look at the depth indicators on that, and you have about 2.5 tons in those tanks per foot. So every day we're checking those, or in between every run, we're checking those depths to make sure we've got our AC supply coming, or make sure we're close to empty, so we can suck tank number 1 completely dry before we put some different binder grade in there, so we don't have any kind of a confounding effect from that. But one of the things you can't see from the control room, there's not a sensor for it until it actually happens, is a no flow in a coal feed bin. And this is one of my favorite pictures from this summer's track build. This was all of the material in the bin when we finished the pave run with this particular stockpile. And so we don't want to waste money by hauling too much material from these long out-of-state distances, but we have to haul enough so we don't go no flow, because you just know it when it happens. You don't have a warning of it unless you're up in a secure location where you can observe it and then make decisions about the plant run, like we were when this picture was taken. As I said, High Tech Asphalt Solutions provided us with a feed system. They donated the system, and then some of the raw materials that we needed, like the cellulose that was used for the OGFC section that we built. And here you see us loading some recycled tire rubber product into the feed side of this bin. When you run something like plastic pellets, and it's going to be a higher feed rate, like with the plastic pellets, then there's going to be some dumping that's going to have to occur in the middle of the run, and that means you need to use the load side of that system. So if you notice in this picture, we've got the gate up on the load side because we had to load it up with plastic pellets so that it could auto feed while we're producing mix. So I wanted to give you a feel for some of the additives, the dry additive stuff that we used this summer. The two on the left are rubbers, and then the one on the right is the dry plastic that we built in the additive group section that Randy's going to talk more about. The rubber product on the top is Smart Mix, and it was at 12%. It was added at 12% by total binder weight. The dry plastic is added based on aggregate weight, and if you calculate it based on total binder content, it was about 8.5%. And then the rubber product on the bottom there is Asphalt Plus. It was also 12% based on my notes. And I like these close-up images because you can see there's a little bit difference in those products because those are proprietary technologies, but they both fed through that high-tech plant, high-tech feed system without any kind of issues. Here's a picture of the KMA 240 that we used for the Virginia recycle study, as well as recycle sections on the off-ramp where Ben Bowers is the PI. This is the portable pug mill from Pug Mill Systems that we used to build some of our off-ramp test sections. And this is research that was not funded by the agencies. These are all privately funded test sections, but on the off-ramp for this cycle, we went all the way down to base and we put in 4 inches of different types of recycle mix, some foam, some emulsion, some rejuvenated, some with just rejuvenator, and some with emulsion plus rejuvenator. So there's 6 test sections out there. One of those is a hot mix control. So in addition to the 4-inch bottom, we've got a 1-inch preservation thin lay surface that we put on top of those sections that actually relates to the thin lay surface over on Lee Road 159 that's been in service back since 2012. So it's going to be really interesting to see how these sections do on the off ramp. and then ultimately, and traffic on the off ramp is about 3.25% of the traffic that we see in the test sections, based on how frequently we come off the track and actually have our trucks on the off ramp. So we'll be reporting on this in the future for the ramp, but if performance is good in these sections, and if cold recycling continues to grow, then we may have test sections on the track in the next cycle that we'll build in 2024. So we've been doing this a long time, and we have our processes in place that you just got to have faith in. This is a picture of Jim Musselman on the faith front, who's saying a prayer for good performance of AlDOT's OGFC test section that we were in. Matt Sasser's saying a little prayer here that all the gauges that he's helping Dave Tim install in the structural test section survives. And then you got Rex Stroud, our paving foreman, who's saying a little prayer here that the paver doesn't strike any of the gauges. And so he's navigating that paver through those gauges. Many of the test sections that we built this summer were thick paving test sections, and with thick lift paving, in this case, it was about 5 3/4 inches thick for the additive group and additive group plus test sections. We've done thick lift paving as thick as 8+ inches in the past, and when you're paving thick like this, logistics are key. You gotta have trucks stacked up to support paving, because you don't want to stop the paver. And one of the things that's helpful to us, East Alabama Paving, they got transponders in all their trucks, so they know where all their trucks are, and we can run mix at the plant and then make sure they're stacked up properly to support this paving. And I wanted to share this picture with you I guess kind of the most obvious thing is we did a lot of work at night. We worked very long days. Hats off to the team and credit to the team for hanging with us in every phase of our operations, construction operations this past summer. But I like this picture because this is one of our thick lift paving sections, and even though we try really hard to be smooth, these things are really hard to do smooth. And this was paved with a locking screed that has a locking mechanism to keep it from sinking. Just the weight of the screed when you're paving thick like this, but you still have waves that are going to create localized roughness. And our goal with these is to come back and do diamond grinding and get them at around 100 inches per mile. But some of the thick paving that we've done in the past has been as high as 350 inches per mile. So it can be rough, and it takes a lot of practice and a lot of logistical support to get it smooth. So we've now done our diamond grinding, and we have seen some big improvements in our roughness, but I think we're going to have to do a little bit more work on that to get it really where we want it. Of course, that's construction, and when these mixes are placed on the track, there's a massive amount of bulk sampling that's done. So what we do is when material that has been run through the shuttle buggy, we boom it over to a flatbed truck and then haul it around behind the track lab and make a little sample stockpile back there. And we filled up as many as I think the heaviest sample section was something like 300 buckets. It's just crazy. Typically we'll sample maybe 30 buckets. Some of them are extreme sampling events, and it's a team effort. Wow, what a great team we have for everybody pitching in. And when it's 100 degrees and we're sampling hot mix from a stockpile like that. And this is one of my favorite pictures because Jason Moore worked really hard this summer to help us out at the track. And you see Nathan there and Jason there and everybody on the track team, but there are also some vendor personnel that are in there helping us. And, when you got to do this kind of sampling, everybody jumps in and tries to contribute. And we're very grateful for that. So some takeaways from the build this summer. The designs on the lab side can take time and effort with balanced mix design and or the friction requirement. Nathan Moore and Adam Taylor worked really hard at Ncad to stay ahead of us this summer, and especially with the additional friction requirement, that really took a lot of work, and we appreciate the investment that they made to do that. This is really important, I think, because y'all have heard me say this before. I kind of instinctively wear an agency hat and then change over and wear kind of an industry hat because I used to work as a regulator, and then I'm kind of living like a contractor when we rebuild the track. Additive utilization is nothing to fear by either industry or agencies. I'd be confident writing a spec and enforcing a spec if I was with an agency, and I'd be confident bidding a job and building a job and making money if I was in the industry. I'm pretty excited about the potential of additives and what they can do on both sides of the fence. Another observation from this summer is, in my opinion, from my perspective and Jason Nelson's perspective, BMD compliance is, quote, easier than volumetrics. When I get a volumetric design from a state DOT that we have to put on the track, there's so many things that you really want to hit to meet. And BMD compliance really is easier because it's about gradation and asphalt content when we're putting them on the track, which is much more straightforward. We have meaningful quality indicators for agencies, some good options in the laboratory. And then if I'm thinking like a contractor, I've got practical production targets for balanced mix design that are frankly easier to meet and more straightforward to meet than volumetrics. One other takeaway from this summer, and this is something probably Nathan's going to talk about in the future, is he pulled samples and ran samples over to the main lab and did BMD testing at the time of section construction. We also did some here in our track laboratory, and you typically see higher cracking indicators from produced mix compared to short-term aged mix when you're looking at mix designs. And I think that's going to be an important thing for us to document in this effort. We didn't have any difficulty meeting density requirements with this track build. It was very straightforward. I think there was one section that we had to do some additional rolling on. And part of the reason for this is balanced mix design, and part of the reason is because HOM provided us with some really efficient and sexy rollers to use for the track build this summer. And there's our front roller and our back roller and our intermediate roller that are staged out there as we're getting ready to pave out ahead of them. Another takeaway from this summer is you need more bins in mix designs when you have challenging stockpiles. And from my perspective of track construction, challenging stockpiles, you can have some kind of typical quarry gradation variability in a stockpile, and it's not a big deal to the quarry, but it can be a big deal to you as a contractor. So I'm an advocate of put more mixes in your design, put more stockpiles in your design, run more bins, because that gives you more opportunity to fix things when you have gradations that either come in a little different, or you have stockpiles that have some segregation characteristics about them. Regardless, unique bin calibrations are essential with short production runs. So we calibrate every stockpile that comes in. We don't just put 78s in a 78 bin. We calibrate specifically for those materials, and that's really how you get a good match between target tons per hour and actual tons per hour at the plant. And when I've got a volumetric requirement, I love the ability to really control the waste dust. And that depends on your aggregates and the market that you're working in, but that's something that we're gonna that'll be really useful to us in the future. Well, we're in the process now of kind of doing some wrap up work and baseline testing. We got to do some painting and some marking, that kind of thing. But as soon as we're done with all that, we're very close to running the fleet, and so I'm sure we'll have updates for you. Jason Nelson will talk about that when we meet in the spring. So that was all I had to share. Do I have to cancel my screen share, or is that automatic, Ben?
You're just fine right now. I guess, is there any questions for Buzz? I noticed that Randy West talked a little bit about the absorption rates in the chat box, if you want to look at that, related to the question that was earlier about the absorption. They gave examples for the limestone and the granite. Any questions for Buzz Powell? It looked like it looked easy when you presented it. I'm sure it wasn't, as we all know. So with that, Thank you, Buzz, for that presentation. We'll move on to the next presentation. Randy West is going to be talking a little bit about the additive group study construction. He'll talk a lot about the Ncad construction, how this kind of came about and that study. And then Michael Vertis will kind of follow up on how we'll utilize that for some of the test sections in the reflective cracking challenge NRA is doing in Minnesota and those ties between those studies. So with that, Randy, if you could share your slides. And as you do that, just so everyone knows that, sorry about the lobby issues. I was supposed to set up something before the meeting started to prevent that. Now that the meeting started, I can't get rid of it. So sorry about that to the presenters. Lessons learned. So take it away, Randy.
All right. Well, good morning, everyone. Thank you, Ben. Can you hear me okay?
You sound great.
And the slides are showing right?
Yep.
Okay, good. All right. Well, I get the opportunity to share with you a little bit about the additive group experiment. Buzz mentioned that. You know, it's always good to hear Buzz present what is probably one of the most complex things in the pavement world is building cycles at the test track. It's really a master at that. It's so many moving parts and different stakeholders and a tight schedule. So I always tip my hat to Buzz when he does the excellent job that he does, and makes it all interesting. So I'll get into this if I can get the slide to advance the right way. So many of you probably have already heard about the additive group experiment. This is an ongoing experiment with Minroad, partnership with them. We like to sell it as it's a comprehensive evaluation of sustainable, resilient pavement technologies, just to throw in those buzzwords. But really, I think having the partnership with Minroad and our ability to kind of do experiments that span both facilities helps us address national needs, and this is certainly a continuation of that work. In short, what we're doing with the additive group experiment is evaluating a couple different types of additives. We have a couple of rubber modified asphalt sections. We have a couple of plastic modified sections and a fiber modified section, along with a control section. And as Buzz mentioned, we have just completed this rebuild at the test track, and we'll talk about rebuilding or building new sections up in Minnesota next year, sort of at the end of this presentation. Also, just to remind everybody who the sponsors are for this this experiment: Alabama DOT, FHWA, New York State DOT, Florida DOT, Mississippi DOT, Tennessee DOT, and Texas DOT. So they're footing the bill for this experiment. I'm sure there's interest from a lot of stakeholders, both agencies around the country, industry, suppliers, and that kind of thing. The funding this time is a little different. With Minroad sections, they'll actually be funded more through NRA, and there's been a lot of discussion about the selection of those experimental sections there over the last couple months. But what we are still doing with this partnership is using the funding through these sponsors to help us do the support work for the construction and evaluation of the mixes that are going to be put down at Minroad. So there are six test sections in this experiment. 5 are with additives and 1 control test section. And those are designated by the cells shown in gray. So I've gone through the plan before with all of the sponsors on kind of how we got set up on this. First of all, we had to get states to kind of agree to funding the idea, and that happened over kind of the last part of 2020. And then earlier this year, really through the winter of 2020 and 2021, we did what we called the phase 1 experiment, which we invited sponsors of a lot of different additives to send us their material. They funded a small, what we call laboratory or phase 1 experiment, where we used those additives that they provided, did a balanced mix design, did some additional characterization of those mixes to sort of better understand how they would respond in a structural experiment. We shared that that information with the DOTs. So we had about 12 or 13 different additives that we evaluated in the phase 1. We knew that we wouldn't be able to put 13 test sections on the track. So we had to down select from those results, and that happened in the spring of last year. And then we've just built the test sections, and then we'll do the test sections in Minroad next year. The phase 1 work included a variety of different recycled tire rubber additives, a variety of different recycled plastic additives, and a couple different fiber additives. Based on the results of the phase 1 work that we shared with those sponsors, we selected these 5 additives. So there's a wet process rubber and a dry process rubber, a wet process plastic and a dry process plastic, and then 1 fiber. Buzz mentioned also that there are some complementary sections sponsored by BASF and Polyco. They funded completely these 2 sections, S8 and S13. And so they'll be shared in a lot of ways as kind of a complement to the additive group, because we built these test sections in the same way that we did for the additive group. Since they're sponsored privately, we will always vet the results of their materials and their construction with those companies before we share them with the public. So I won't be sharing any data from these 2 sections today, because we have to go through that vetting process for making sure they're comfortable with doing that. So the scope of this project is very comprehensive. We've built the test sections, and we'll evaluate the performance of those test sections, with our normal weekly process to evaluate rutting, cracking, smoothness, friction, all those kind of things that we normally do on the test track on a regular basis. As you'll see in some of the slides later in this presentation, all of these sections were instrumented by Dave Tim and his group of graduate students and engineers here at Ncad. And with that instrumentation, we're able to really monitor closely the structural response to the loads and the environmental changes that occur in those sections. And we'll see how they respond, both stress and strain kind of properties and deflections, those kind of things. At the same time, over the next year or so, we'll be doing a lot of the laboratory testing on the mixes, materials characterization, both the traditional acceptance type test, the BMD type test, as well as those tests needed to do kind of a structural response input into any of the ME type models like per road, flex pave, those kind of things. So it is a very comprehensive scope to help us evaluate these materials that we've built on the track. We built all of these sections to the same thickness with the same base and subgrade. We built them intentionally at a thickness of about 5.5 inches. And that thickness we expect to result in bottom-up fatigue cracking within the cycle. And they are all instrumented with strain gauges at the bottom of the asphalt, pressure plates at the bottom of the asphalt, top of the base, and the top of the subgrade. So we'll monitor the performance with these sections. One of the things that I do want to mention, I don't have a lot of full details yet to share with you, but these were built as one lift, which is a little bit unusual. The test sections that we built for South Carolina DOT last cycle in 2018, we did a section that was roughly about 8 inches thick, and we gained confidence in our ability to do that. We do know that building sections that thick, we're able to get density, but we're not able to achieve the smoothness that you would in paving multiple lifts. So what we've already done is to diamond grind all of these sections to an acceptable smoothness. That data the first round of data has been generated, and Jason Nelson is kind of sharing some of that preliminary data with me, but I haven't completely discussed it with him before we share it with anybody else. All right, so this is just another reminder of all the things that we do at the test track, including producing the mixes that Buzz explained about, instrumenting the sections, building the sections, collecting materials, doing all the laboratory characterization, trafficking the sections, monitoring the performance, including friction, as necessary, doing forensic investigations of failures, and then sharing results with you all, with all the sponsors and stakeholders through these kind of sponsor meetings. And we hope that in the near future, we'll be able to get back to kind of live in-person sponsor meetings. So I'm going to show you some of the pictures from test section builds. And I won't go through a lot of the narrative of these pictures. They kind of speak for themselves about what's going on. We did have one section in N2, in N1, built on the same day as this section that we did not get pictures of, and that's the Liberty Smart Mix dry GTR product. So Doug, if you're still on and you took some pictures of that section being built, I'd appreciate if you share those with us, because we certainly like to have that and be able to share that. But a lot of these pictures will look the same. It's sort of the same base mix design for all of these sections. And so intentionally we built these as, kind of comparable sections. This is with the ACE fibers. Fibers were blown in. Interesting thing, it was added, through a metering process that they have developed and provided to get the right amount of fibers, per ton of mix, and it's actually fed onto the wrap belt. You can see Buzz mentioned computer control mixes, mix production. I like this shot because this is where the mix is being unloaded from the shuttle buggy. You can kind of see in the background there the shuttle buggy. That's not riding on the test section. It's boomed over to drop the mix into the paver hopper, which you can see on the bottom left here. But this does show that the fibers are in the mix, and so this is kind of the shroud that goes around where the mix drops out of the shuttle buggy boom, and you can see some dingleberries, as you might call them, where the fibers are kind of clinging on to the mix and holding the mix. I didn't have any negative feedback from production placement of the mixes, though. I think that went very well. So just the normal construction operations and compaction. I'll share with you some of the preliminary data results after I show you all these slides, or these photos. S6 is a generic dry plastic. It's a low density polyethylene rich. It's not 100% low density polyethylene. but it's a waste product, so it's going to have some other types of plastics in it. Buzz showed you another photo of the pellets. They're pretty small pellets, fed again in with the high-tech fiber machine. Is typically used to feed fibers into mixes like SMA and open graded friction cores, but works well for a lot of these other types of additives like the plastics and the dry rubber. Again, you can see we're paving right on top of the subgrade. Paving operations, you see the mix before it gets compacted. Here's a shot showing the instruments, the strain gauges that have been covered up. Looks like cow patties. Looks like somebody let their cattle loose on the test track, but that's the mix that's been kind of screened off, and it is actually the same mix being loaded into the paver there. And that's what it looks like after it's built. Dow wet plastic, again, just conventional type paving, nothing kind of remarkable about this mix. I didn't get pictures of the binder at the plant, but it would probably look just like any other binder. So here's kind of our first glance at some of the data from the construction. The target asphalt content for all these mixes was 5.6%. When we went through the phase 1 work, we actually did multiple asphalt contents for each of these additives, and we didn't plan on end up saying we would use 5.6% asphalt, total asphalt content for all the test sections, but that's the way it turned out. So it looks like everything's kind of a drop-in approach. That's not necessarily the way that we started out planning the experiment. However, that does make it simpler for us as we kind of do some comparisons. So really the only difference between each of these test sections as designed would be the additive itself. Now, we didn't hit exactly the target on all the production mix, but we were pretty close. 5.7 for the control on the asphalt content. For the dry rubber, 5.3, so we're a little bit low there. And then 5.8 for the wet rubber process. The dry plastic, 5.8. Wet plastic, 5.7, and the fibers, 5.5. So generally pretty close to the target of 5.6. I'm not going to show all the gradation, just a couple key sieves. Passing the number 8 sieve, 41% is our target. We're pretty close to that, within about 3 or 4% on everything. The percent passing the 200, our target was 4.3. We did a really good job of controlling the dust content. You can see 4, 4.3, 4.1, 3.8 was our lowest dust content, 4.0, another 3.8. We did run already 2 performance tests, and we did this on mix. The samples were compacted hot. There was no reheating at all. Probably what we will use as our real point of comparison for lab results will be reheated plant mix, and we're working on those test results right now. Should have those very soon. But the first test results that we did have completed that I want to share with you are the CT index from Ideal CT test on the hot compacted samples. The control mix 101, the dry rubber 64, the wet process rubber 41, the dry plastic 40, the wet plastic 74, and the fibers 94. And during the mix design, I didn't put the data here because it's really comparing a little bit apples to oranges if I put the mix design CT index, because those were, short-term aged. I guess it would be comparable in some regards. But anyway, I didn't add that data here. But we did see that kind of differences from mix to mix. We didn't expect them all to be necessarily better than the control. And then the same thing for, this is the hot compacted ideal rutting test. If you're not familiar with that, I'll have to find some pictures to show you what that is. But that's a new test. There has been some research done on this. It's also a test developed at TTI by Fujizhou. We also have high temperature indirect tensile strength, and those two tests correlate very well based on the limited data that we have. But the control temperature RT index of 85, the dry rubber 91, wet rubber 128, the dry plastic 144, the wet plastic 83, and the fibers 98. So higher number giving you a better result for rutting resistance. In-place density, you can see the data here. We're trying to get above 93, and we certainly achieved that. Got good density, as Buzz mentioned before, in all of these sections. So we have more data to collect. We haven't cut cores yet. At least I don't think we have them yet to verify thickness, and some of the other data that we'll have for these different mixes. We'll be sharing those in the weeks to come. So I'll pause here and see if there are any questions about the Ncad additive group sections before we go into the min-road sections, planning for the min-road sections.
Yeah, I don't see anything in the chat box, Randy. If people want to unmute your phones, you can ask Randy a question at this time. Quiet group today. I guess that's okay.
I have a question for you, Randy and Buzz. You mentioned that, especially Buzz made a point to say that using additives should not cause agencies any additional stress. But you also talked a lot about how good the plant was at EAP that y'all use. Are you as confident using additives at any plant across the country? Or can you talk a little bit about some of the precautions that you would first take taking additives to a different plant?
I'll say first and let Buzz jump in there in a second, but all of these additives have been used at a variety of different plants around the country. So I have not heard of any plant limitations. East Alabama plants, their plant does have more equipment than a lot of plants, but the plant itself, the base plant itself, so an Aztec double barrel plant, one of the most common plants around the country and probably around the world. So it's not necessarily a real unique plant. You saw that we had fiber feeding systems or a feeding system to add these different dry additives, and there's a lot of plants that are very comfortable with doing that around the country. Buzz, do you want to add anything?
I would just add that's a great question, Michael, and I think that's why this stuff is such a good fit for balanced mix design. I mean, we have to figure out what everything means, for the various additives and how it all relates back to actual performance. But that's the whole purpose of the experiment. I think there could be some slight differences from plant to plant, but like Randy said, I don't think they'd be a huge deal. If I'm an agency, the biggest concern that I would have is if you're working on a really high tonnage job and you're going wide open and then there's a supply chain problem and you run out of an additive that you're supposed to be adding to the mix, how do you monitor that? How do you police that? And that's why I think this is such a good fit for balanced mix design, because where you might not see an impact on volumetric testing, we would expect to see some impact, on the BMD testing that we would ideally be doing during construction. So that kind of those are my thoughts on it.
Thanks, Buzz. Yeah, obviously we're looking ahead here in Minnesota to construction next summer, and during your presentation, I was envious of the plant you were using, and then at the same time, wondering if we can do it here in Minnesota and how we're going to pull that off. So thanks for answering the question.
All right, let's, if you would, Randy, could you take the question from Travis as Michael gets his presentation up and running? Can you see that, Randy, in the chat box?
Yeah, Travis has asked, he says, I noticed the dry process, that's the dry process rubber, had 0.4 less AC than the control. What we have seen is that the rubber also absorbs and swells from the AC. Thus, we typically need to add a little extra AC to keep the same effective binder. Do you think we'll be able to pinpoint performance coming from the dry rubber process with a much lower AC? The Smart Mix dry rubber that we had, and Doug, I think, is on the line to kind of correct me if I say something wrong or add to something if I don't say enough, is a pre-reacted rubber, and so the swelling has already taken place, and so it includes in the additive, the oils that I guess have already taken care of that absorption that you're talking about. Now, we would have liked that asphalt content for that mix to have been, the same as the control. We do our best, and Buzz always does a fantastic job, and everyone that's involved does a really good job of, kind of making sure we're as close as the target as we can get. So that, 0.4 lower AC, total AC for that mix, could have an effect. I'm not going to sugarcoat that, but we'll continue to look at that as a potential, issue with that. We may be getting some more cores later, and we can verify asphalt contents with those kind of samples that we get a little bit later on.
Randy, I would add to that's one of the QC, that's some of the QC data that I'm kind of suspicious about. That mix has a really high correction factor, and we did furnace testing on these mixes, during construction, and I'm suspicious about that number, but that's what we measured in QC, so that's what we reported, and I think we might find when we do some additional testing that the actual number is a little bit better match than that. That's my thinking on it.
Hey Buzz, do y'all happen to have some type of solvent extraction you could run to verify that? And the only reason I'm asking is we've had some test sections here where I guess unofficial test sections, it's just kind of demoing products, and we've done some of these dry process type rubber products, and typically a fairly high AC mix to begin with, and then with the rubber, you put in a few extra tenths, and at the end the supplier says, look at the great performance, and the question has always been, well, is it from the rubber or the additional asphalt, and what's already a pretty highly asphalted mix? And so from an owner perspective, is it worth paying the additional money for this product on top of a few extra tenths binder if I'm not going to see the real performance? Could I have just cut out their product and added a few extra tenths and called it good?
That's a great question, and we do have the ability to do solvent extractions and solvent testing, and I'm sure we will do that. As this is just kind of raw QC data, and from my perspective, I think there's two reasons why the data from this experiment is important, and one of them is so you can make financial decisions about investing in different technologies based on the return on investment you're going to get from a performance point of view. And then the other side of it is if you have some kind of a mandate, if you're forced to use technologies, then what do you need to plan on the impact of that being? So it's important for two different reasons, and we will do exhaustive testing in the main lab with this massive amount of research mix that we sampled during construction.
Hate to cut this off. Carolina, do you have one quick question?
Comment. I think I agree with Buzz that it will be good to revisit those numbers, because if you look at the IDLCT, they are not, for the Smart Mix, it's not the lowest. I think it's like 60. So I think that may be something that we will want to double check the AC content. That would be somehow reflected in the city index when you have a lower AC content, and that city index is actually relatively close to what we got for the mix design. A little lower, but not extremely lower.
Okay. Randy, did you have any more slides?
I do, yeah. So I'll
Why don't
start
you
sharing.
finish up with those? And again, for Michael and Randy, I do not have a lot at the end to speak for 10 minutes, so we do have that time, but we don't want to go past the hour. So Randy, go ahead.
Okay, well, Michael can jump in here a little bit to talk about this as well. As I mentioned when I opened up, this is the partnership with the Ncad and Minroad. The Minroad side of this is the additive group is within or part of the reflective cracking challenge. So Michael, do you want to talk about this slide and the next slide, which has got kind of the slide that you want to add about the milling?
Yes, and then I have a couple slides that I'll take over and share, just kind of pointing out the differences between this study and a typical Ncad partnership study. On this slide, really what the whole intent of this is, we're trying to match our test sections to the majority of the bituminous paving that we're doing on our state network, and that is mill and overlay conditions. So with this, we are building a 4-inch common base area or common asphalt structure. Within that 4 inches, we are going to saw cut these reflective, so a 200-foot portion, basically half of our test section, we're going to put transverse saw cuts in the lower lifts, and then we are going to place a unique surface mix on those saw cuts. So we're having an even comparison in our 10 different sections of a reflective cracking situation over the same structure at the same location, which we're not able to do if we used an existing pavement or test section just to the random nature of reflective cracking. And then we also have 200 feet of our typical comparison where we have the mix without saw cuts. Everything will be built with this common mix in the bottom 4 inches and the shoulders at this time. That common mix is going to be a typical MnDOT mix for this project. However, we're going to be using a unmodified -28 binder instead of the -34 binder that would be specified in Minnesota for an overlay project at this location. We chose the -28 because we do want to have some or more movement within the structure that we can kind of capture and monitor the reflective cracking and the cold performance of these sections. So the Ncad sections that Randy was talking about were designed for bottom-up fatigue cracking, and these sections we are monitoring just the surface performance of the lift in respect to reflective cracking. So I mentioned, and you can go ahead and click through the animations, Randy. I mentioned that we are really trying to better mimic what we're doing out in the field. And part of that and part of the Caterpillar partnership that I discussed in this morning's presentation, we're able to, and if you keep clicking, Randy, there should be more stuff that pops up. So we're able to bring in a milling device after we pave and mill the top inch of the surface and then pave our unique mix on top of a milled surface. And what that does for us, again, kind of better matches what we're doing on the network. And it also provides us a better bond underneath that unique mix with the existing structure. One thing to point out on this slide and the last slide, the exact spacing on the last slide, I believe we showed 25-foot spacing for our saw cuts. The exact spacing is something that we're going to be working out over the winter as a project TAP or technical advisory panel. We want to put in sufficient space between the saw cuts that we have movement, but we don't want too much movement and too much space between that we're developing thermal cracks within kind of the pre-prescribed saw cuts. So we want some modeling and some careful consideration as far as the number and the spacing of the saw cuts that'll be used. Can advance.
All right, do you want me to take over here?
Sure. And I
Okay,
can,
well, this is probably something that Michael can speak to even better than I can. So the reflective cracking challenge, which is an NRA overall experimental plan, includes 10 total test sections. And then 5 of those will be additive group sections. They may or may not be the same additives that are used at the Ncad experiment. I'll talk in the next slide about the mix design process. But we will have 5 of the sections in this challenge to be with different additives. Then there's also plans to build 2 control sections, one with a 52S minus 28, kind of a standard grade, and then the other was a 52H minus 34. So a polymer modified binder, with a lower PG grade on the high end, on the low end. And then also NRA's Flex team have had several meetings and discussed kind of the overall experiment. I think we've settled on the other sections in being an SMA mix, and then a HYMA or highly modified asphalt mix with probably a smaller nominal maximum aggregate size of 9.5, whereas I think everything else we're thinking 12.5. And then the last one would be the SuperPave 5 mixed design approach that's being used in Indiana, and several other states are now exploring as well. Anything to add, Michael?
no, I'll add a little more details in my slide.
Okay, great. Mixed designs, we plan to get raw materials next month and start doing the mixed designs. We'll do the balanced mixed designs with the same additives in phase 1, and perhaps if other companies want us to do some additional work, we'll consider that as well. It'll be obviously with the materials in Minnesota and the binders that they have. In the Ncad mixed design work, we did not do DCT, obviously, because we don't have too much thermal cracking this far south. But we will add that as kind of our low temperature cracking assessment for mixed design. We may add other cracking tests. We certainly will add other cracking tests in the overall experimental plan. And just like I explained with the Ncad sections, we'll share the mixed design data, both the BMD results and some of the modeling work, to agency stakeholders sometime in the spring of next year, and kind of let that group kind of weigh in as to what the 5 additives are for the min-road sections. And then when the sections are being built, Ncad, including Buzz and several others, will be up there, just like in 2016 when we built the cracking group experiment up there to support construction and sampling and all that kind of stuff of the materials, and bring them back here for additional testing. So that's the plan for mixed designs and construction. And I think that's it for me. Michael, I'll stop sharing here. So if you have other slides, you can share those.
Yeah. All right. So I just had a couple of slides just to add some additional clarification. really wanted to talk about what is an NRA Tap. So the TAP is the Technical Advisory Panel. And as Randy kind of mentioned, we've had a lot of meetings throughout the year, throughout this year over the last several months. And in my opinion, they've been very, very productive, more productive than I was even hoping for. And it's come to an experiment and collaborations and mixes that I think we all have an interest in, and we're all kind of proud of what we've came together with. So the whole objective of the TAP, in my mind, is to kind of guide the project, but really it is to maximize the outcomes for everybody. So me as an agency member, I have a little bit different agenda or what I want to see out of the project than someone or than a contractor or someone in industry. But at the same time, our projects should be meeting everyone's agenda and can. So really we're involving different opinions throughout the project and at different stages. If it ever comes down to stuff that we need to make a decision or there's a lot of disagreement on, the agency members do have kind of the overarching authority because they pay a higher dollar amount for membership. But in general, we avoid those kind of situations and really try to accommodate everyone because, as you all know, we advance the industry and advance economics and environmental benefits by moving together and not just as one entity. Our NRA TAPs are open to all NRA members to participate. So if you're interested in more about the NRA or the TAPs, please send us an email. And one thing I do want to point out is the Ncad additive portion of the reflective cracking challenge is going to be managed by Ncad, and they will have the final say as far as the products used, the experimental design. Really, we want to keep the integrity of that experiment within the reflective cracking and be sure that we're matching and maximizing the benefits of the Ncad Minroad partnership that we've seen over the last 5 or 6 years. Really, we have a national effort, as Randy mentioned, with the Ncad and Minroad partnership. The NRA's efforts on overlays began in 2017. We had a Minroad section on our original I-94 concrete alignment that did asphalt overlays over a 50-year-old, pretty severely poor load transfer, bad joint situation at Minroad. I would encourage everyone to go and check that work out if they have not. So this experiment we're doing now is kind of the next progression to Dr. Ishan Dave's work on the previous NRA sections, but now we're carrying that effort to bituminous over bituminous or HMA over HMA. Another unique kind of national contribution, we were approached by Missouri DOT and the Missouri Center for Transportation Innovation, MICT, with interest to do another kind of companion spin-off study with this and with the Ncad sections, where they are doing field sections in Missouri, in the Missouri boot heel, where they're looking at asphalt overlays with different additives, different SMA structures. So another piece that gives us another region and another application. We can use some of the tools that were developed from the University of New Hampshire in the 2017 project and carry those directly to another asphalt over concrete project and provide more links between the work that we're doing. I'll skip through the mixes quickly that are being used in Missouri. And just back to the slide that Randy showed, I just want to highlight some of the mixes that we have. So that the Ncad dry plastic, Missouri has a similar section planned. The dry rubber, Missouri has a similar section planned. And then the SMA, the one difference from what Randy presented with the SMA is that we're planning on using recycled content. In our region, we have a decent amount of confidence in our SMA mixtures. We really want to see if we can get that quality with more recycled content and reduce the amount of virgin material in those mixtures. And then the other thing that I've added to this slide, mixes 9 and 10, the high polymer 9.5 mix, and then the super pave 5 mix. Those were also the best performers in our 2017 work here at Minroad. So one of my favorite parts about the Minroad Ncad sponsor meeting is the last 5 or 10 minutes. So instead of talking about more instrumentation and future plans, I want to open it up to the group and have some discussion in the limited time we have.
Yeah, Michael, I wanted to add a couple things. I know Randy
Please.
showed sympathy cracking for the Minroad test sections. We thought it was better instead of doing 8 quote test cells to do 10. That's how I removed that 100 feet from each of those. So we're only doing 200 feet of non-sod mix, if you want to call it that, and 200 feet of sod mix. So we'll both have the low temperature cracking and the reflective cracking as a part of it. The other thing to mention is that the NRA will be sending out RFPs for this research on this work. That is expected in the next week. For a few of them, we have 8 different projects that we'll be sending out RFPs to. So we'll be sending that note out to people, telling them that that's available now to get proposals on. But I think the reflective cracking is one of the first groups that'll be coming out, and that'll be 30 days to respond to that. We did have a couple questions on FWD testing and right around the thermal crack, and I'll quote the thermal crack that we're creating with the saw. We'll come up with a process to do that. That's a really good idea. Cold and recycling treatments. It kind of came down to real estate and how much space we had and what we could do, to answering a couple of things on the chat. Are there any other questions out there like Michael asked for? Okay, Doug Carlson had a question there about dry rubber additive. I'll let you handle this one, Randy or Buzz, if you would. We only got a couple minutes left.
Okay, well, he's just clarifying, the smart mix technology. I'll just read his comment. He says, the dry rubber additive smart mix is pre-swelled with extender oil about 20% by weight of the rubber and is delivered in a saturated surface dry condition. Typically, mixes will not require additional binder as the rubber absorption issue is already addressed. So I think he is somewhat confirming what I said before.
All right, thanks, Randy, and thank you, Doug. With that, any other real quick question? A lot going on, a lot coming out. Again, we all appreciate your support in these efforts that we're doing. Without you guys, we wouldn't be doing the research that we're doing. So again, we thank you for that. We are looking forward to developing the mixes here at Minroad and getting them out and having discussion this spring. Again, Ncad will be sending out a note trying to set a date for that spring meeting, I think in the near future. Not speaking for Buzz or Randy on that, but they'll be getting that out and kind of go from there. Michael kind of made a comment there on the CIR. You can see in the chat. But with that, I think we'll be, again, thank you for your time and support, and thanks for all the speakers for sharing today. Appreciate it. I think things went well. So thanks and have a good day, and we'll talk to you all soon. Bye now.